Bueno, hola, muy buenas tardes. Gracias por...
Good afternoon. Thank you for coming. We are going to be talking about modern enterprise solutions. And to go a little bit into further detail in relation to what we've seen yesterday, and we're going to focus on the back end and its architecture, and it's going to be a bit more technical and conceptual. Now, to start, I'd like to tell you a little bit about my childhood. I was born upcountry in a German colony. I had to walk 4.5 kilometers to go to school. It was a rough road, and my parents had a dairy farm. And on my way, next to the road, next to the path, there were fences, wire fences, and some of the fences. This is a typical fence. We call it a lay. It has 7 rows, and it's thought for no cattle, no bovines or ovines to cross from one place to the other. They are the limit, the boundary from one field to the other. This is absolutely new, and this makes me think that someone pulled everything down and built a new one. There were this type, I could find this type of wire fences on my way to school, but there were others that weren't perfect. Particularly, I remember one whose owner would walk around the field, and it would take one of these clubs, let's say, and he would walk around, and from time to time I would see him standing next to one of those fences, and he would replace the old ones that were broken by the new one. And so he would be, he didn't follow the strategy of pulling everything down, because when you pull everything down, well, you don't spend money for a long time, but then sometimes I start having problems with my neighbors, and when cattle start crossing, and then when its pressure is too high, I have to disperse a lot of money. This other neighbor, I never saw him, I never saw any of his cattle crossing over, but he was all the time mending his fence. And this talk is to think about the strategy that we're going to follow together, so as to make modern applications, but not only to make them, but also to keep them up, to keep them updated. So this is what the talk is about. Some functionalities of these modern solutions, I mentioned them yesterday, and some of them must be composable, maintainable, evolutionable, portable, a conceptual level. The others, we have to think about the architecture or the components, performance. It should be scalable and observable. And these are characteristics of modern solutions. This is the way we build them. They must comply with these characteristics. And the other thing is, how can we do this? Shall we do it in a sustainable way along the time? I, for one, believe what this neighbor of mine thought. I don't like to pull everything down. I belong to Brogan Gonda's school, that you have to build on what it's built, and that's an enormous difference. This talk is about that as well. I'd like to share all this with you and see whether this helps you to continue that approach. So we're going to go over these various characteristics. The first one is composable. what does it mean when a solution is composable? I'm going to make a solution. I'm going to think of the various components of the solution. I know that that solution is going to be standing alone, and I'm going to think about the various components. I'm not talking about technical architecture, whether these are micro, mini service, or whether it's a monolith and each one of the components. What I'm talking about here is the package business capabilities, that is, components or modules or conceptual modules at a very conceptual level that could be implemented with many microservices, but that solve a true reality. For instance, the purchase tray for mini commerce, or that forms part of a very small part of something that's much bigger. This is a strategy that is one of the most important ones to follow. It's considered as one of the trends in the industry and something that must be developed in industry. And then for one of these components to be composable with others, again, it must have certain characteristics: modularizable, reusable. I have to deploy every model, and I have to maintain it. And in a dynamic manner, I must compose the systems and or the subsystems of my solution. And all this must be done in a governable manner. I have to be able to govern the life cycle of each one of these components. Gartner sees this as one of the most important points in the strategies of companies, that is, composable. And Gartner isn't only putting it among the most important trends and the things that you have to look the most at IT levels, corporate IT, but we also have to describe, he describes in his report the things, or what is this good for. And he sees that this is going to have an important technological impact. I'll be able to evolve technologically with each one of those components if I think about the solutions in that way. And on the other hand, it has a business impact, because I can sell these modules separately, and I have an independence. And I'm independent to compose it with other modules and generate business. So what Gartner says is that these modules will help the company to become more resilient vis-a-vis any adversity, to adapt to new needs. And all this is within a framework where, unfortunately, disruptions are more and more frequent. And sometimes they undermine the opportunities we have. Gartner goes beyond this, what I'm showing you on the screen. He says, why is it that we don't use, or that companies don't use this that frequently? And on the one hand, it's because they don't know it. They don't, IT managers don't know how to build this. And then on the other hand, they see there is a lack of tools to facilitate building these systems. And that's at Gartner International in the reports. So we're going to see in GeneXus what the main characteristics are to be able to build these systems. On the one hand, we have modules. For many years, we have insisted on modularizing our database and providing some functionalities in GeneXus to facilitate it. So you can have a module, and you can share it and reuse it. For instance, if a KB has certain modules, those modules, the interface of those modules in GeneXus and the implementation at low level may be shared with the module server. For instance, in Nexus, we are supporting that. That's a repository manager. And that module may host other modules from other KBs, and the various KBs may download the modules we developed in order to reuse that implementation and have an interface available in other KB to invoke functions that have already been developed. And in that way, at knowledge level, we can reuse it. If we go a little bit further, it's not only procedures or data providers that we have in those modules, and the design systems can be reused, but this year we added something that means that we can do the same with APIs. I can design an API object in a KB, I can deploy it, and so that API has the gRPC service or the REST service, which is implementation of that API. You can already do it. You could already do it in previous versions. There is an open API description, and I can import it to another KB, and from then onwards I can deploy an app. That's one approach. But a better approach that allows us somehow to go further up in the versions is the next approach. Again, you use a modules server. I package it in a module. I package the API. I take it to the module server, and that is imported to another KB. And there I have an interface that's available for that API to be called. And I start programming in that other KB. Before calling the service of the API, I say, well, what's the protocol that I'm going to use for the call, and where the implementation of that service is located. And with this and some other lines, but these are the main conceptual lines I wanted to share with you. They are in KB2, and so you call the API, and the rest is to deploy the solution. And in that solution, you're going to have the customer, or you're going to have the customer layer of the API implemented in order to make the call to the real REST service deployed by KB1. So when I'm developing API, I can also share it through the modules server. I said something about composable and composition, not only about these modules, but we also have a dynamic composition. And in super apps and in mini apps, we can see a dynamic composition of components in GeneXus. For instance, if I develop a super app here in a KB1, and this is a mobile native application developed with GeneXus, I deploy that super app. I don't know if you've seen the example of Itaú of super apps in the demos. Those super apps offer an API to mini apps. So you can have many mini apps running in the super app, and those mini apps may call a certain interface of the super app. And that super app also has an API declared in the super app object. And the approach I'm going to follow here for mini apps to call those interfaces is exactly the same you've had with any module. I'm reusing the same concepts. I take the super app in a module to the module server in the other KB. I would import the module, and it's already available. The API is already available. I call it from programming the API. I deploy the mini app. I upload the declaration of the mini apps to the mini center, mini app center, and there all the lines are going to be uploaded. And there, the following step is that the super app will call the mini app center, ask for the lines available, and upload one directly. And when it's uploaded, it's executing the mini app in the environment of the super app, and the mini app can call the super app. And so the circle is closed, and I've used the same concept for these objects, and it's possible to do so in the latest versions. This question of APIs will be available in the upgrade in September of GeneXus 18. And this super app is working from upgrade 6 that has just been released. So all these are functionalities that you can already start using. This is part of the progress made this year all along the modules.
Así que por ahí los avances nuevos.
So that's our progress, so that you can compose solutions dynamically. We'll keep on working on this next year to allow more objects to be part of those modules so they can share more and more within the modules. This is the road we will follow and augment. The other topic is governability, the life cycle management. And in GeneXus, I have GeneXus server, the module servers for the repositories, the mini app center for super apps and mini apps. In the mini app center, you govern the life cycle of the mini app, so you don't need to load it in the super app. Just by a click, it's all in runtime. And whoever is managing the mini apps that can be loaded into the super app. And when I generate those issues, those sources, the sources can be generated with Jenkins and others, and you can manage the whole pipe to release the life cycle of the solution that we have generated so that it goes to production. So we have all the elements that are required to build solutions and maintain them updated. These are the characteristics that we just went through. And now we'll move into the next group. So far, we talked about composable. We'll see how maintainable they are, portable, and evolutionable. And that the basis is clearly GeneXus, because we are based on GeneXus. We describe the reality on a database with artificial intelligence. We generate programs and databases. We can help the systems grow and evolve. In this sense, we maintain the generators always updated, and at any point you can generate for the latest technologies and maintain your technologies always modern. If we go into the other characteristics of one of such components, we would like to maintain the performance, the scalability. All of that can be embraced in one concept, which is cloud native. To take advantage of the server's power of the clouds and the services that clouds provide, so that our applications can scale up and be performing. So these architectures can be as complex as what you see on the screen. This is from Microsoft. This is how Microsoft understands a cloud-native application. You can do the same in GeneXus. And to make it easier, we have added some concepts in GeneXus, also capabilities to deploy, so that you can deploy to Amazon or Azure, and in those clouds use all the services that they offer, so that your applications can scale up and have disaggregated components. Other components may scale up more than others, and so on. This is something that we will expand into other clouds. I'm showing only two. We are not excluding the rest, only that some of these services or the concept of functions has been developed for Amazon and Azure and not for Google Cloud. So Google Cloud can develop something that is scalable. That's no problem. Only you have to use other strategies, like containers. So, of course, it's our responsibility to expand all these concepts to embrace more companies. providers. To facilitate this, we developed examples like this one. Here we have a very complex architecture with different queues for messages, functions that awaken every now and then, functions that awaken through message queue, and so on. This is for Amazon and for Azure, and we have also developed for them an infrastructure as a code so that all the solutions can be set up. One thing is to have programs running in this architecture. The other thing is to create the whole network and set up in Amazon so that the functions and data are supported. So that's why we need infrastructure as code, and we release code in GitHub, and you can download and use this architecture and know how you prepare this architecture. You can do that for your different cases. Now here I'll talk about the progress made regarding cloud native and the different concepts we support. What are those functions and services that we support? And I will double click on one in particular where we have worked, and that's observability. When we have several components running and one solution embraces many components and the flow cuts across many of them and the flow breaks up in execution time, it's very difficult to detect when errors are occurring. And this is where the concept of observability comes in. I must identify where something is happening, and the knowledge is such that I can take steps regarding the situation to correct the problem. So there is a standard for this purpose, which is called open telemetry. If you follow that standard, if you implement applications with this standard, then automatically all the tools that analyze the logs, the traces, where you really see the flow go by and the trace of the application, there are specific tools, they start working if the applications inform correctly about what's happening. So with GeneXus, what happens is that we automatically have all that information being sent correctly and following the standard so that those who analyze can show the information and those who operate the application can make decisions. This is what we do in all these cases, and we are also doing it for the whole backend automatically. And we are also building an API to provide more information, more semantic or business information in those logs. And our future work is to offer this in native mobile and go to the front end of work to have the whole traceability from the click to the back end, cutting across all the layers until the database is reached, and all the information will be there. So now we have all the back-end observed information. Of course, all these characteristics are met. Also security. And we'll move into the last point, which is sustainability. Once again, all improvements in terms of sustainability, even though GeneXus helps in the life cycle of solutions and maintain them and help them evolve incrementally, GeneXus was contributing a lot. And in future, it will contribute even more because we have AI in place. We use artificial intelligence to capture knowledge, to have more information about requirements in the KB. As we describe the reality with more information on that reality, and if we can store more data on that reality in the KB, specifically, not just today's descriptions of what we need to do, but also the intentions that we the intention with which we want to provide the solutions, then that system will be even more sustainable in future, because I will be able to reuse those intentions in future. In simple words, the more information I have in the KB, the more I will be able to process in the future. The better knowledge I have, more code can I produce. So how about AI in this age? Well, more specifically, you've seen that GeneXus Enterprise AI was released. This is a module that goes between your application and the access to the language LLMs and other models. This is what you developed at the top, and this will connect with the LLMs through a connector, which is GeneXus Enterprise AI. So here we have another solution that is created with GeneXus specifically and meets all these requirements. So if we integrate with that activity, that part will be sustainable, it will evolve, and we will be able to create solutions that are portable, that do not have specific lock-ins, that our solution will scale up regardless of the scale required for enterprise AI or the LLMs. So independent and sustainable as well. And that is GeneXus Enterprise AI. I'm creating and composing solutions and providing wholesome, complete integration covering all the other solutions. And GeneXus Enterprise AI was developed with a concept that we call API first. Before having a back office or a manager to work and operate enterprise AI, we developed APIs. Why? So that that module could be integrated into any system. So this is the progress made this year, the most relevant aspect, so that you can create, maintain, and evolve unprecedented software solutions. I leave you then with this question. And you, how will you maintain your fence?